Hi folks, Andy here with the series of videos on SolidWorks in CAD and engineering. This tutorial that you're involved in now is to help you make output from your CAD model. Now, the simplest and first way I want to show you is if you're going to be 3D printing things, to show you the process for doing that. Here's my my CAD model. Now, as you recall, this is an assembly. If we try to make a 3D print format file for this, unfortunately, what we're going to end up getting is the whole thing. So when you're doing 3D printing of multi-part assemblies, you really have to open up just the part itself. So here I'm at the bottom, I'm just going to select open part. We've been through that before. And I've got this part, which is the base of my CAD model. There's a few things that you might want to do before you actually try to 3D print this. Depending on what type of 3D printing you're using. But in general, one of the things that you'll find is that sharp corners like this, really with almost any manufacturing method, they're a risk, because if you're machining something, for instance, where you're using a tool to cut it out of a block of solid material, well, the tool that you'll be using to cut it doesn't have an infinitesimally sharp point. So you can't make a really sharp inside corner like that. You can make a sharp outside corner, so those aren't a problem for manufacturing. They sometimes are a problem for handling, and you might want to break those corners with either a chamfer or a radius. But these inside corners, you're definitely going to want to radius them. So if your model has inside corners like this one does, then before you go to 3D print it and save the file in a format that you want, you might just want to take a fillet and pick some reasonable radius. I'm going to use a 0.5 millimeter one. That's just going to put in a little bit of a rounding feature in there. Like so. Now, I didn't knock off these sharp corners. Maybe I'll do those as well. No particular reason, just that it offends me to see them like that. And if I save that, I haven't changed the function of the part very much. I've just made it easier to manufacture, and I've made it so that that corner will no longer be there when you build this part as kind of a place where a crack can start. So that's a good thing. I also realized that I left this radius here. Maybe I think I used a 2 millimeter radius on some of the others, so I'll just put that there. I guess I used bigger than 2, but I'll just leave it at 2. That wasn't necessary for manufacturing, but it was there. So with this now, I've got a base that's going to be sharp, and I've got this edge that's going to be sharp, and this top edge that's sharp. And I could take this directly and send it to a 3D printer. It's not really the best part to be 3D printed, because as you can see, there's a lot of kind of wasted material in the center of this thing. And the 3D print material is kind of expensive, so we don't want to waste it. This part, just for quick look, that's 24 millimeters thick. That's pretty thick. And I don't need all of that. So before I 3D print it, I could hollow it out. Now, there's a couple of ways I could do it. Hollowing this out, I could simply just do a cut on this face here. And that would be a little bit of effort. Or I could even just do a shell. I think I'll do a shell. I'm going to make my shell quite thick, make it 10 millimeters. And I'll make the shell that I'm not going to include that. Let's see if that works. Oh, it doesn't like the curvature that I've got there. So maybe I won't do a shell. So what you'll find with the shell command is that it really wants these radii inside to actually be on par with the thickness of the material. So I could shell this much, much thinner, but not really necessary. So rather than that, what I will do is pick this surface and I'll do offset entities, and I'll pick that whole surface. I want to offset inside. And yeah, that looks, maybe I'll even go a little bit more. And when I cut that, I can cut it blind, or I can cut it offset from a surface. So I can pick this surface and I can say I want to offset that by 4 millimeters. There, now I've saved some 3D print material. I still have these inner sharp edges, so I'm going to get rid of those. 2 millimeter radius is good. Maybe I won't pick that edge, maybe I'll pick that whole loop. Yeah, there we go. There. Now I've made the part that was otherwise going to be quite expensive with a lot of 3D print material. I've gotten rid of some of the material. I haven't sacrificed anything in terms of function. I even have the holes that I'm going to drill here are not going all the way through. I was going to make that make the model transparent, but oh, there's what I want to do. I forgot what environment I'm working in. Yeah, so you can see that my hole through doesn't go all the way through to the shell. Wouldn't really matter if it did or not anyway, but now I'm using less material. If you're curious about how much material you're actually using, you can just go to evaluate, look at the mass properties, and it says the volume is, in my case, 130 grams or cubic millimeters. I work a lot in that, 130,000 microliters, or this is essentially 0.13 liters, or I guess that's 131 mil. And the 3D print material that you might be using is expensive in terms of mil. This 130 mil for this is probably something like $15 worth of 3D print material in one machine, and then that can be less. So we're looking at a part that might be $15 or $20 to 3D print. So you could tune that down a little bit if you like, but that's basically it. The last step that we would have would be to export it as an STL. Oh, one final note, these holes, these are to be threaded, but when you 3D print, most 3D print machines aren't fine enough resolution to actually print the threads. So that's just going to print as a whole, and then you can chase it with a tap, which is a tool to make machine threads. So with that, we'll go up here to Save As, and it opens up a window, and you'll see that there's a bunch of options for the format that the part you can save it as. Is if you save it as an STL, which is just a file format, you can select options with regards to the tolerance of the STL. I would just leave them at default for the moment. And it will come up with a name that's similar to the one you've had for the part, and we'll just save that as an STL. And if it's a multi-body part, there might be multiple bodies. In this case, I'm just going to export all the bodies. And there we have it. So that part will be saved as an STL. You can send that STL file to have it 3D printed. We can talk at greater length about what the requirements are for 3D printing and what makes a good model and not, but we'll leave this for now. Thanks for watching.